Supported by international climate finance, the first living lab unfolds in the Pacific Ocean, on the low-lying nation of Tuvalu. Here, the first group of researchers and collaborators arrive. Their role is clear: to work alongside Tuvaluan communities to co-develop solutions grounded in local and planetary realities. The site, Funafuti, a thin stretch of land formed by a ring of islands surrounding a shallow lagoon. One side is densely inhabited. The other, a sanctuary for over 400 marine species. Beyond the island, the seabed drops sharply, making traditional coastal protection unviable, despite sea level rise threatening the livelihoods of the Tuvaluans. The living lab is anchored near the urban core, with satellite labs dispersed around the island. Patches of coral shape the seabed. These rhizomic organisms inspire the growth logic of the living lab. Just as coral expands in response to environmental conditions, the living lab follows a branching system that allows it to grow over time, adapting to population changes and spatial needs. This branching and curling structure defines distinct zones within the lab, weaving through the existing reef landscape to create areas for testing and recreation. The main frame forms the structural foundation of the living lab. As needs evolve, the frame allows new modules to be added, repositioned, or expanded, enabling the lab to grow in response to environmental conditions and community dynamics. The first of these branches begins with the deployment of the lab cluster, the heart of the living lab. First established near the urban core, the lab cluster addresses key areas of focus related to the 9 planetary boundaries. Solutions for marine restoration, sustainable food systems, and community resilience are developed here. The first phase also includes the education of local residents and the installation of wind energy generation points at high wind zones across the island. Centered around an energy-productive tower, the lab cluster begins with collabs where researchers and locals collaborate in shared open labs. For more specialized usage, 2 types of lab modules can be deployed. Type 1 modules are above-water modules for dry lab research, data systems, and policy prototyping. Type 2 modules are for aquaculture, reef studies, and environmental sensing, types of experiments involving constant access to water. The lab cluster remains open and visible, allowing research to be conducted in full view of the community. In this lab module, researchers explore marine hydroponics, growing salt-tolerant crops using seawater-based nutrient systems. Solutions developed here move directly into the living cluster, a space where new systems are tested and integrated into daily routines. The spatial layout of the living cluster draws from Tuvaluan vernacular architecture, where movement between daily functions flows through shared, open spaces. Within the living lab, this layout becomes especially important, bringing together researchers, locals, and regional migrants into a shared social and spatial environment. Here, housing is modular and arranged into living groups, based on the average household size in Tuvalu of around 8 people. Each living group shares access to a communal kitchen and bathroom. Housing units are equipped with solar panels and rainwater collection systems. During shortages, both systems transition to community reserves, collectively managed to ensure fair and reliable distribution across the living cluster. The living pavilion sits at the center of each living cluster, a reflection of long-standing Tuvaluan tradition of communal life, where social bonds are maintained through shared spaces. The living cluster grows in stages. In the first phase, commons are spaced across the main frame. Early residents settle around these nodes, leaving gaps for future migrants. Over time, the gaps fill in, allowing the community to expand gradually, while keeping growth inclusive and adaptive. Embedded within the living clusters are the productive commons. Here, marine aquaponics systems are tested and refined, with input from both researchers and residents to develop practical and scalable solutions. Surrounding the commons are education hubs, offering training and essential skills for future generations. While the Living Lab was first established through international climate funds, what happens next depends on what the world does or doesn't do. In one scenario, early climate action begins to show results. Living clusters remain concentrated near the original lab cluster, focusing on refining systems. But as momentum fades and climate conditions worsen, new living clusters are established to accommodate displaced locals and regional migrants. Amid this uncertainty, China steps in, accelerating the lab's growth and asserting leadership in climate adaptation at a time when the U.S. retreats from its global climate commitments. New lab clusters are established, part research platform, part strategic foothold in the Pacific. The world begins to watch Tuvalu closely. More nations invest and send their researchers onto the Living Lab. But at the center remains the social contract, a shared agreement that ensures the Living Lab stays collaborative and grounded in reciprocity. What began as a local experiment becomes a planetary prototype for resilience, for cooperation, and for the futures we choose to build.